This video is about the idea of electric charge. Charge is a property of matter that causes matter to experience the electrostatic force from other charged objects. The more charge the object has, the more force it will experience as a result of another charge. The variable we use for charge is Q, and the unit is C, and it stands for Coulomb, who was a scientist associated with electricity. So charges can be positive or negative. Like charges repel each other and opposite charges attract each other. So you'll remember by Newton's third law, if one charge puts a force on another, the other will put the same force back on that first charge in the opposite direction. So you can see by that picture on the bottom left that opposite charges attract by putting equal and opposite forces on each other, and like charges repel by putting equal and opposite forces on each other. Charge is also conserved. It cannot be created or destroyed, only moved from one object to another. There are only really two types of charged objects in the universe, the proton and the electron. All charge that we experience only exists because of the number of protons and electrons in an object. So there's no other source of charge in the universe. It's just protons and electrons. And protons and electrons have the same magnitude of charge, but opposite sign. So the charge of a proton is 1.602 times 10 to the negative 19th coulombs, and the charge of an electron is the exact same thing, but an electron has a negative charge. So we call this basic number the elementary charge because you can't get any smaller than that. You can't really get a charge that's smaller than that because all charges come from protons and electrons, and there's nothing with a charge smaller than protons and electrons. So all charges really just come in different amounts of the elementary charge. So this means that the charge of an object must be a multiple of the elementary charge. So you can have 1 protons or 2 protons of charge, but you can't have 1.5 protons of charge. That's not possible. So because it comes in these very specific amounts or numbers, we say that charge is quantized, which is a physics way of saying that it comes in specific quantities and it can't take values between those quantities. Charge in an object comes from an imbalance in the number of protons and electrons in the atoms that make the object up. Just looking at this atom, for example, you can see it has 4 protons and 4 electrons. The electrons are in the outer shell. So if I add up the charges here, there are 4 positive elementary charges and 4 negative elementary charges, and so the total charge on this object is 0. If I take away one of the electrons, you can see that it now has a positive charge that's equal to the charge of 1 proton, because the 3 electrons are canceling out the 3 protons, but there's 1 additional proton of charge, so the charge on this atom is now 1.602 times 10 to the negative 19th. And I can keep doing that. I can take away more, and you can see that as I take them away, the charge increases, but it's increasing by the elementary charge. It can't take a value between 2 elementary charges. And so the most positive charge this atom can have is 4 times the elementary charge. I can also add electrons, and then it becomes a negative. This leads to a very important observation. Electrons in an atom can move and often leave or join the atom. So they're in the outer shell and they can leave the atom pretty easily and move to other atoms. Protons, in comparison, are stuck in the nucleus. And therefore, when the charge of an object changes, it's almost always because the electrons moved from one place to another, and almost never because the protons moved. So therefore, even when an object becomes positively charged, it is much more likely that this was caused by losing negative charges and not by gaining positive charges. This is going to be a really important concept. Basically, all changes in charge come from the movement of electrons, so even if something becomes positively charged, what that actually means is that it lost negative charge, didn't gain additional positive charges from adding more protons. One last note, you'll have to have a basic understanding of the difference between a conductor and an insulator. A conductor is any material that allows electrons to easily move through it, and an insulator is any material that does not allow electrons to easily move through it. Insulators can still be charged, but the charges stick in place in the insulator and do not move. So common examples of conductors are things like most metals and water, and examples of insulators are things like rubber, air, us, we ourselves are pretty good insulators, wood, things like that, so on and so on. So that's what you need to know about electric charge.